Hey everybody, good evening. It is we're back. It's Wednesday, middle of February, feels like the middle of April. It's awesome. I'll take it. Uh so let's see here. Since we're on Monday, we are reaching the midpoint of the course. Um Tonight we're going to kick off Project 5. Now, I know Project 3 we'll do tonight. Some people are probably still finishing it up. And Project 4, you haven't started it yet, but what I want to do tonight is sort of the way the course is paced. In order for us to focus on mob programming next week, I wanted to kick off Project 5 to sort of give you a demonstration, give you an introduction to it. My goal here is twofold. One is to make sure that you can build Project 5 in your environments. And so then if you're in a position to do so, please, play along with what I'm doing for at least the beginning of it when we create the new Maven project for Project 5. But then also to sort of give you an idea of what it's all about. So then as you're looking forward to the next couple of weeks before the project is due, um, because actually, I guess it's due 2 weeks from tonight. That you can plan accordingly and sort of have a good context for what you'll be focusing on. Uh, so yeah, and I think so. Yeah, so we'll kick off Project 5 tonight. We'll see it, and then next week we'll do mod programming, and then after that we'll come back to the REST API program to Project 5, do some refactoring to sort of get you back into the code base after Project 4 is done. But first, let's talk about what's been going on. So, like I said, Project 3 was due tonight. How did it turn out? Okay. Yeah, any key takeaways, anything you want to share with me? Anything I think you found either insightful or challenging or things you'd like me to know?
Yes, for me, this is my first time refactoring all of my unit tests.
Oh yeah.
The command line parser, so it's made a whole lot of refactoring decisions throughout the entire thing.
Okay, yeah, good. Lots of refactoring. Okay. That's just a happy, well, it's a side effect. I think it's a happy side effect. You might not be so happy about it. Yeah, of the changing requirements. Well, good. I'm glad you got to experience that. And so I guess good. I think it means that the timing of the refactoring discussions we had over the last couple of sessions that maybe came in handy. Good. I'm glad.
Also made me realize how bad my tests were for the first project as well.
Oh, bad. How so?
I just like, I could make them more concise, I could just
Okay.
write them better so that it would be more inclusive, rather than something changed, it's still
Yeah.
fast and stuff like that. Just showed me how young and naive I was at that.
Oh, yeah. 3 weeks ago. I know, right? Yeah. It was a simpler time. Yeah. No. But good. I think that yeah shows that you're learning things when and right. And this is the thing. What took me so hard. It took me so long to learn this lesson. That it's you know. Yeah, you make mistakes so you can learn. And really, as long as you only make the mistake once, right? That's fine. That's good. That's a good mistake. It's the mistake that you make over and over again, where it's like, oh, okay, the lesson really isn't sinking in when you do the same thing over and over and it doesn't work. Yeah.
I guess it's also kind of nice to be able to offload the daytime parsing
Mm.
to like the job built in.
Yeah. Oh, yeah, great point. Yeah, so now that you're leveraging the Java Time APIs for your parsing your date and time parsing. Yeah, you can delete a bunch of code and sort of a bunch of logic that again, sort of like with you saw with those fresh eyes of weeks 1 and 2 are probably much cleaner now. Nice observation.
Yeah, and betting the value and like testing, make sure it's they've done it right.
Exactly. Yeah, no reason to test the JDK code. Presumably, it's better tested by people that know a lot more about things than we do. Nice. Any questions from people online or anything that you'd like to share with me or the rest of the class about your experiences in Project 3 or really in anything over the last couple of days? Anybody had an opportunity to dive into Project 4 yet? Anybody started thinking about it? That's fine. And I will say Project 4 is brand new, and so the tires haven't been kicked on it. So if there's something that doesn't work or doesn't make sense to you, please reach out. I think everything ought to work. But if there's something, especially with the database or accessing the database that is confusing, or you get an error that you can't work around, please speak up, let me know, and I'll be happy to engage on that. It is due a week from tonight. We'll do a check-in next week to see sort of how things are going. Again, if people are encountering problems, we'll do the right thing.
Thing that kind of struck me when it was assigned last week, it's a customer schema, it just has two fields, ID identity and
Yeah, did I get that right?
name bar chart. I guess that's wondering like, was it intentional to have the primary key be the name?
Oh my gosh, that's totally a bug. Yeah. Sorry. The identity should be can you send me an IM about that? Just DM me and just that way I'll fix because there was something else I needed to fix in here, wasn't there?
The character count.
Oh, right, the character count for the 9 to thank you. Okay, yeah.
I think it implies that customer names have to be unique. Great.
No, they don't. Here again, it's the identity that should be the primary key. You could have two. Oh, I see. It's like, should they be unique? Yeah, they probably should.
Text files don't have requirements.
Yeah.
It has to- Someone's going to wait, it's like, wait, is that a very, very?
Oh, yeah, it's a good point. Should they both be primary key? Should be a compound primary key? I don't know. Well, let's see here. To be clear,
You have the same name.
you could, but there's no, the command line doesn't support, or the command line is the thing that says the semantics of the command line application are really what ends up enforcing the uniqueness of the customer name, right? So, there's no, if the only interface to this is the command line, which for Project Forward is, then it's, and the semantics of the command line are, oh yeah, if you have, you go and look up to see if there's a phone bill with that name, it'll end up being unique anyway. So I suppose, well, maybe the name is the primary key. I don't know. Yeah, just get to work. We'll find out. Yeah.
The primary key that affects like the layout of disk or something like that. I'm getting this, is it like,
Oh,
that's like you get like an index on it, so it's lookups faster, so like.
well, let's see. I guess it probably depends on the database. I don't know if by default there's always an index on a primary key. It might, or whether there's like an externally facing index, or if it's just like how it's stored. Yeah. In this case, it's not going to matter. Obviously, not going to have that much data, but good thinking though, right? When you design databases, especially with any scale of data, yeah, you need to be thinking about indexes and how to optimize. And if this were in course of databases, we would talk about all of that. But this is like, hey, everything you need to know about databases in Java in 1 week. Oh, thanks for bringing that up. Oh, yeah, JDBC dumper. I should probably call this database dumpers instead, but whatever. Sweet. Okay. Anything else I can tell you before we dive in? Yeah.
Guessing that they're natural keys, right, and not using surrogate keys or anything.
Yeah.
Database group.
Yep. Yeah. Let's keep it simple. Yep. Okay. So we're entering the second half of the course, and the coding gets a lot more interesting now. So, really, certainly the first 3 projects, even the first 4 projects, everything is in a single application, a single program. Its program execution starts with your main method. It goes off and does a bunch of stuff, maybe works on files, works with the database or whatever, prints out some output and then exits. And this is probably a very familiar programming pattern to you. You've probably been doing it since, the first program you ever wrote. I think it's a good way to get started with the course, get familiar with the language and the build environment and testing, right? All the things you've learned. The second half of the course, the programs get more complex, more real, I hope more compelling, ultimately. I think it's proven over time to be true. So with the first thing we learned about in the second half of the course is REST APIs and working with web applications. And because this isn't like a course in just web applications, where we kind of take a simple approach, which is writing a REST API. And the content covered in that Foundations of the Web lecture is really meant to give you sort of the low level way of building Java web applications. And so there's something called a servlet, which I hope you learned about in the lecture, and we'll talk a little bit about it tonight. That runs inside something called a web container, which is essentially a web server for Java programs. And the servlet is this object. So you're used to objects that working with objects that you invoke, right? So when you create, an array list or a linked list or whatever it is that you use, or when you create a local date time, right? That's an object that you create. You interact with it. It probably goes away after some time, goes goes to the garbage collected heap, and then it is automatically managed. Servlets work a little bit differently in that, well, they're like a long-lived object. You start up your web server, you start up your web application, and there's a servlet object that is sitting there, is waiting for someone to talk to it, right? So for most of the time, it just sort of sits there idly until web request comes in. And when web request comes in, that request is routed to the servlet that has the application logic that turns that request into a response. And this is a fundamentally different programming model than you might have seen before. Now, I think some of you might find it natural, but some of you might find it very unnatural too, and that's fine. I know for me, sort of when I went from very synchronous programming to asynchronous programming, like my code, I don't know when it's going to be invoked. Whatever the user does is when it invokes it. It was kind of a bit of a mind shift. So beyond all the API, beyond all of the the new ways of testing that we'll see with REST APIs, just be forewarned that it's a different kind of programming. You're going to have not only asynchronous programming for your servlet, but you're going to have multiple processes talking to each other. You're going to have a Java program that is your web, it is your REST API, is your web application, and you're going to have a command line program, which is a client to that. And so again, it's asynchronous programming, it's concurrent programming. It might be a little different from what you've seen before. So let's dive in. So Project 5 augments the phone bill application with a RESTful service. And as you learned or will learn in the lecture, REST is basically a programming API that is implemented using the concepts and the protocols from HTTP, from the Hypertext Transport Protocol. And so what you'll do in this assignment is take your phone bill application and sort of split it in two parts. One is the user interface part, which is a command line program like you've been working with all along. So that should be mostly familiar to you. And then there is the server-side component, the servlet, that implements some of the phone bill management part of the application. And the nice thing about this is that you can then have two programs talking to each other, and as we'll see, you can access that same REST API both from the command line tool and then from a web browser. Before I really go into the details of the assignment, I'm just going to scroll down here to where we talk about making a new project. So for projects 1, 2, 3, and 4. You created the project, early on in the class, and then you started working with it, you evolved it, and did more and more stuff. And because the first 4 projects are all command line projects, right? It was all sort of fundamentally the same kind of structure that you were working with. But in project 5, because now you have these servlets, it makes most sense to start over with a new project. You'll copy some of your code, things like your phone bill class and your phone bill, your phone call, your text parser, your text dumper, your pretty printer over into this class, into the project, because as we'll sort of see, there's a whole bunch of new stuff in there in order to have the web application. So, oops, that should be project 5. My apologies. So let's see here. I wonder if I messed that up in the project too. So as always, let's see here. So it's been a while since we've created a project, and so as you recall, we need to do that from the PSU machines. So then I'll log into the PSU machine as me. I'll go to my checkout of the Joy of Coding for winter 2026. I'm going to do a Git pull. I don't know if I've actually, wait a second. Let me get this started. Okay, good. I'm up to date. Oh no, I'm almost up to date. Okay. Oh, lots of changes. Okay, cool. Oh, right. I had that GitHub pages done. Great. Okay, so now I've got my checkout all up to date here on the PSU machine. And so I'm going to run the create REST API. Sorry, create REST project. Whoa, sorry. Really? I just locked my screen. Smart. Not so smart. Come on. There we go. Let's try and move this thing out of the way. I think I can just hide that. There we go. Much better. We can run the create REST project script. And creates a new, a new project. Nice. And so now you should see changes to, the pom.xml, because now there's been a new project added. Yeah, there's a new module, there's a new submodule at the top level project, new top level POM called phonebill.web, sorry, phonebill-web. And yep, there is a new file here, a new directory called phonebill-web with all of the information. So we're going to do git add of the POM, the change for the POM, and the phonebill-web. And now from status. Great. We've got a whole bunch of files here. And when we bring this up in IntelliJ, we'll see this. But there's a bunch more. Oh yeah, it's called Project 4 instead of Project 5. My bad. When I teach in the summer when there's only 8 weeks of the course, the REST API is Project 4. So I just forgot to rename it. We'll rename it in IntelliJ shortly enough. But there's a whole bunch of stuff that interesting that it comes out of the box. Some things that might be familiar, like a main class and some integration tests. But then I provide example text dumpers and text parsers. And you'll just copy yours from the real project 4 from the database project over into this one. But there's also some new code, like your phone bill servlet and this REST client, and they have tests and stuff like that. So we'll take a look at all that stuff here shortly. So I'll just commit this and I'll say add REST API project. Yeah. Good. Okay. Okay. Those of you who are following along, everything working okay? Were you able to create the new Maven project? Okay, good. Seeing some thumbs up. Okay, cool. So please commit all that, push it up to GitHub, because now I'm going to go over to IntelliJ on my local machine. I'm done with the PSU machine. Yep. And actually, the first thing I'm going to do is I'll go over here to my this is my Joy of Coding. Yep. And I'm going to say git update project. And so it'll bring some stuff in. It's fetching stuff from GitHub. Yep, looks like I found some stuff. Great, 23 files in one commit. That sounds about right. And let's see here. Now, yep, I have a phone bill-web project here. If your project isn't in bold, go over, find the Maven tab, Maven panel over here on the right, and you can use this synchronize. You can either sync all or if reload all, and that should get IntelliJ. That should make IntelliJ aware of all the stuff in your pom.xml file. So, okay, good. I've got the project. I want to make sure it builds on my local machine. So I'm going to go to the checkout. Let's do push D. Git coding winter 2026. Yes. Great. It's got the phone bill web. I'm going to go into the phone bill web directory. And I'm going to do a Maven W clean verify. So the one of the nice things about Maven is it has really great support for web applications. And so then actually what this does is it builds all parts of the web application. I think it goes really fast on my new machine. That's nice. And The web application has sort of the same build phases that you're used to. It has, compile the source code, run the unit tests, um, assemble the artifact. But here, instead of the artifact just being a jar file, it's a jar file in something called a WAR file for a web archive. And so if you look in your target directory, you'll see that there is a phonebill.war, which is the thing that's deployed to the web container. We'll talk about that in a little bit. But back to the Maven project. So the Maven project still has the same build phases, but the build phases do more in the REST API project. So they build additional artifacts. You end up with a command line tool, which is the PhoneBill client .jar, and then the server-side code, which is the WAR file that contains your servlet and a static HTML page. We'll see in a little bit. Then the Maven will run the integration tests. Now, we'll see this. I'll emphasize this a couple more times, but the integration tests for the web project, for the REST API project, are much more interesting than they were in the first four projects. So for the command line projects, right, your integration tests test the command line, and they use that invoke main, utility that I wrote to basically, make it so you can write a unit test that captures standard output and standard error. You still got that style of unit test in the REST API project because you have a command line utility. But in the REST API project, you can also write tests against your running web application. So the integration tests for the REST API project, when you run them, the first thing they do is they start up a web container, they deploy your web application to it, then they run the integration tests, and the integration tests basically call the REST APIs. And then then they shut everything down and they verify that everything passed. And the thing I think is really nice about this is that it still feels very familiar. You'll still run the same commands. You'll say clean verify or just run the integration tests. And it will and it'll sort of behave the way that you're used to. So we ran that and everything was clear. Oh, and by the way, of course, you also get code coverage and all that kind of good stuff because it's Maven. Okay. So let's take a look at the application running. We'll get to the code, I promise, but let's look at the code. By the way, did people's projects build okay in their environments? Yep. Okay. Nice. Okay. So I've been talking about this web container thing. And actually, let me go back to the assignment. Where's that picture? I drew a picture. Gotcha. Okay. So remember how I was saying that this program kind of is in two parts? There's the server that runs, and there's a command line program that starts up, talks to the server, and shuts down. I don't know. I like boxes with arrows between them, and so then this is the picture that I have in my head of the client and the server. So we'll talk about what's over here on the right first. So this is something called, this is the web server. It's a web container. Web container is basically like a Java program that runs these WAR files. And it's called Jetty. It's an open source project. I think it's from the Eclipse Foundation originally. And it's the thing that runs your PhoneBill servlet. And we'll see what the servlet is in a minute. This has got all of the code for managing the phone bill. So adding phone calls to it, querying it. We'll see how all of that works here in a little bit. And this is and so this is the thing. Oh, and then because it's a web container, it you can access it through HTTP and really any HTTP client. So you can use you can use this Java client here that will talk HTTP to the to the container. You can use a web browser, you can use curl, right? It's all HTTP. That's the nice thing about REST APIs is that because they speak a very well-known protocol, all you need is a client that can speak HTTP, and then you can invoke that REST API. So let's take a look. Sorry. And then the web container runs on a given host, and we're just going to run it locally. So the name of the host will be localhost. And then on port 8080. And so ports, if you're not familiar with the concept, is basically like this conceptual hole in the back of your machine where the internet comes in and out. Basically, that's how it connects that's how it connects to the network. Every machine on a network has an IP address, but we're really talking about host names here. And then it has a whole bunch of ports that various programs can run on to communicate. And so we'll use port 8080. which is a sort of, common development, application development port. Yeah, especially for Java programs. Okay. Let's run this thing in action. So if we want to run the web container, this thing over here on the right, we tell Maven to launch Jetty. Again, Maven has really great support for web applications. So we say Maven, we use the Jetty plugin with a goal of run. And so what this thing will do is that it'll build the web application if it needs to be built, and then it'll start up Jetty and it'll deploy the web application to it. And it did that nice and quickly. And it tells you that it's running here on, well, this, binds to the local loopback and on port 8080. So now I've got this. So over here on my right, my web server is running. And so what I can do over here, actually, let me make my window a little smaller here. There we go. I think I want both on the same screen. This look okay. I'm going to create a new tab over here in my web browser, and I'm going to go to localhost. Okay, sorry, I'm going to go to HTTP. We're not going to do HTTPS because certificates, my God. Localhost port 8080. So you can watch the lecture if you want to learn all about URLs, but right, the whole idea of URL is it's the location of something on a network on the internet over the HTTP protocol. And so you give it protocol HTTP and you say : the name of the identity of the host and optionally a port. So it's going to be localhost port 8080. And so if we hit this, we get this page saying, hey, listen, 8080 wasn't found, but what Jetty will serve up by default is a list of the contexts, the applications that have been deployed here. And as you can see, it shows that there is a context called phone bill, and then it has some information like, hey, what's the name and as it started and things like that. So we can navigate to the phone bill, by clicking that. And when you do that, this static HTML page is displayed. Just a note about this. This is something they use for demo purposes, and because it helps me interact with the application through HTML. It's like super old school, like 1995 style forms and stuff like that. So yep, it looks ugly. And this is, to be clear, this is mainly for demo purposes. If you want to use it to test your project, fine, but you don't have to. You can't submit it. It's not, you don't. This isn't part of the official part of the project. But like, hey, if you are super familiar with HTML forms and if that's how you think about interacting with this, so you develop your project, sure, go ahead and use it. Actually, it was the original version of this was developed by one of the students. It's like, hey, I found this helpful. I'm like, great, do that. Yeah, interesting. So ultimately, this project is going to be your phone bill project, but out of the box, what you get is a simple dictionary application where you can, define words in a dictionary. And what that does is that sort of demonstrates the end-to-end workflow. It gives me something to make sure that the foundations are solid. And it gives me something to demonstrate here to show you how, how the project's laid out and how the project works. And so what we're going to do tonight is I'm going to give you an introduction to the project, maybe show you how to debug it, because you've got two programs talking to each other, so the debugger really helps. And then after we do the mob programming, I'll show you how to refactor the project into something that looks a lot more like a phone bill to give you a head start and just get you used to the code and how to test it. Okay. Done a lot of talking. Any other things that we've discussed so far? Is there anything you want to dive into? Anything that could use some additional explanation from me? Okay. Hopefully it makes sense so far. So over on the left, you've got a client to your server, and you can do a number of things with this little program. You can get all the dictionary entries, you can get the definition for a word, or you can create a dictionary entry. And so then when you click the submit button, it actually invokes, it then makes the HTTP request to the server running on the right. So if I click submit here, it returns a blank page because there are no entries yet in the dictionary. But as I hope you saw over here, this was logged. This get all dictionary entries. A message was logged because I called get all dictionary entries. And actually, if you notice, when I did that, the URL changed. So when I click submit, what it does is it loads a different URL. In this case, the URL is the /calls URL. So it's, localhost 8080/phone bill/calls. And so, what the form does is it loads another HTML page. It makes a different HTTP request. In this case, it returns nothing because there's nothing defined. Let's create a dictionary entry, and we'll do doe, deer, female deer. Click submit here. This will hit a different URL that will create an entry in the dictionary. So when I click submit, you'll see over here it logs, so it interacted with the server, and it was a post request, and we'll talk about a post request here shortly, and it defined the word doe as a deer, a female deer. And then there's a message that's returned here to the browser that says define doe as a deer, a female deer. Okay. So what we're seeing here is how the client and the server interact with each other. So this is what it does, right? The client will request various URLs, either as using the get verb or the post verb. And then the server over here responds accordingly. And this is the application, this is the logic of your program, right? It's what your web server does as it gets various requests. So we've defined doe, deer, female deer. And now when we ask for the definition of a word like doe, we click submit. Now it says, great, I'm getting doe over here. And it returns, well, this is actually the pretty version of the definition of doe. It says doe colon a deer, female deer. And note the URL right here, right? The URL is, we'll close up colon 8080/phone bill/calls word equals doe. So, in the lecture, I talk about, URLs and all about URLs, and URLs can have, they have a location basically, and then you can have a query as part of that location. And here there's a query parameter called word, and the value of that parameter is doe. I hope all these concepts are pretty familiar to you. You've used the web your entire lives probably, but I don't know if you've ever really studied or learned about sort of how all this stuff works. That's the intention of the web content in this course. This isn't a course in web programming. We're not going to be doing JavaScript. We're not going to be doing large scale REST APIs and things like that. We're not going to be using coding frameworks to generate REST APIs. It's pretty low level. It's pretty fundamental stuff. And I think that's what we can fit into 2 weeks. And I think that's things that you might not get in other classes that are more high level. So if things seem a little clunky or like, wow, I'm dealing with some low level stuff. Yes, that's true. And that's intentional. So I defined a word, doe, deer, female deer. I looked up that word. And now when I get the list of all entries, it returns one doe, deer, female deer. Now, if I do ray, drop a sun. It defined it again. And so over here, it did a post, an HTTP post. And now if I get all entries, I get doe and I get ray. And that's what this program does out of the box. Pretty straightforward stuff, right? Hope it all makes sense. And I hope you've seen that, there's sort of a client, there's a client on the left and a server on the right. Actually, what I'll do now, I'm going to open up another, and I'll make it a little bigger. I'm going to open up another window. Oops, no, it's too big. Oh, it doesn't work like that. This is not Windows. Try this one. Yes. Please make it smaller. Okay. I'll go to that same directory. I'll go out to the checkout of my code and joy of, nope, sorry. CD PSU, get table joy of coding, order 26. Nice. I'll go to that phone bill web directory. And now I'm going to run the command line program as part of the project. The command line program is also a client of the REST API. It's also something that makes HTTP calls, and it does essentially the same thing as the web does, but it does it from the command line, from a Java program. So I'm going to run java-jar target phone bill client.jar. This is very simple. It takes a host, a port, and optionally a word, and optionally a definition after the word. And it does the same kind of things that the that web page does. So here we go. Host name is going to be localhost. Port is going to be 8080. If I invoke it with no arguments, it's going to print out the entire contents of the phone bill. And it's got two things. Now, the reason it's got two things is that it interacted with a server, which is still running over here. So I used the web page to populate the dictionary, and the dictionary is still there. It's stored in memory. It's still running. And because the web server is still running over on the right-hand side, then when the client on the left accesses it calls the same APIs. The server doesn't care which client calls it exactly, and so then it just returns the same content. And same thing over here. We can define a new word, me, a name I call myself. And so through the Java program now, it's doing the same thing that the web page did, and it sent a post. The server doesn't care who the client is, because the client followed the rules, used HTTP, sent in, had the right parameter name set and everything like that. It knew how to handle it, and now it defines it over here. And again, now if I go back to the web browser, and if I just reload this page, so this URL just gets me all the calls. So when I reload this page, yep, now it's got me a name I call myself. I can make that a little bigger, perhaps. So again, it doesn't matter what the client is, as long as the client follows the rules of REST, it's going to do the same thing. Conceptually, making sense? Things you want to explore some more? You're good? Okay. Okay. Something I want to call out here is that this data is stored in memory. For project 5, the goal is to learn about REST. The goal isn't to do data persistence. You've done data persistence to death, right? You wrote, phone bills to files. You wrote to databases. You're done, right? You've demonstrated you know how to do that, and so just keep it simple. In project 5, you're just going to store the data in memory. So just have a couple, have phone calls or have phone bills in memory. What that means is that the web server, when it goes away, you lose all your stuff, which is fine for this project. So I Control-C'd it to shut it down. Now, if I try to access the API, it can't be reached. The server isn't running. Okay, let's start it up again by running Maven Jetty run. And now, if I reload here, the phone bill is empty. So if I run here on my command line, again, I'll add me a name I call myself, and look, it's back. Okay, so right, so there is, the dictionary outlasts multiple calls to the API, but when you shut down the server because it's stored in memory, you lose it all. And you can all imagine how to save it and then bring it back. You'll have to do that for project 6 for the Android project, but let's not bother with it for project 5. So to be clear, you won't be using you will be using your text writer and text and text dumper, sorry, your text dumper and your text parser, but you won't be using it to write to a file. You'll be using it to write it to the client. So yeah. So maybe at this point, it would be good to transfer to go back to the assignment and talk about more details of the assignment. So fundamentally, that's what we've got, right? You've got this web server that will store a phone bill, and then you've got this Java client that the user uses to interact with the data in the server, and the data in the server outlasts multiple calls from the client or multiple invocations of the client because the phone bills that are managed reside in memory. Okay, looking once again at the project. Let's go back up and start talking about the requirements of the project. So now you sort of understand how it works. Let's talk about what it's going to do. Okay, so we'll talk about what the servlet is in a bit, but it's the thing that it's the thing that implements the REST API. It's the thing that knows how to respond to HTTP requests. And there are and so what I specify here are the URLs that you support. Now you'll notice that out of the box, what you get is the URLs are properly implemented. So even though it's a dictionary, so it calls itself a phone bill. And that's because I don't want you to have to figure out how to reconfigure the web application. It's just like another step. I want you to focus on implementing the logic. So you don't really need to change the configuration of the web application itself as much as you do implement the code that's already there. So even though the application, the domain that's being implemented is a dictionary, it's still like the servlet is still called the phone bill servlet. So the whole idea here is that you've got this URL, so it's slash phone bill slash calls question mark customer equals name. And if you just say question mark equals name, it'll return all the phone calls in the phone bill. Actually, it'll use the text dumper to dump the phone bill associated with that customer. So this is interesting, right? The transport the wire protocol for this application is your text representation of the phone bill. So ultimately what you'll send back over the wire and actually what you'll send back over the wire is your text dumper. And then on the client side, on the Java client side, you'll use your text parser then to take that text that was sent back from the server and then create a phone bill object so you can then work with it, like pretty print and stuff. So get will return all the calls. So we'll return a phone bill using the text dumper. If you do an HTTP post to this URL, and you can look at the lecture to understand the difference between get and post. This is another verb that you call when you make an HTTP request. The post is what creates a new call in the phone bill with a given customer name. And so then here is where the client will pass in all the information that it needs to create a phone call, just like you did in the command line. So the customer name, caller number, callee number, begin and end. And note that the format of the phone numbers and the dates are the same as in Project 4. So the 12-hour time and all that good stuff. If the phone bill for that given customer doesn't exist, you should create a new one and store it in memory. So actually, this is an important distinction. Well, actually, that's not true. Just like Project 4, the database project, Project 5 manages multiple phone bills, so multiple customer phone bills. So projects 1, 2, and 3 with a text file, there's only one at a time. If you wanted to have multiple customers, you'd have multiple text files. Here, nope, the server, just like the database, can handle multiple phone bills. So that's some new functionality there. There is another piece of sorry, this functionality is probably familiar to you, right? You've been doing it for like 4 projects now. There's a new piece of functionality in Project 5, and that's the ability to query a phone bill. So in this URL, this is the same calls URL. It always has a customer name, but if you also provide a begin and an end parameter, what this will do is it will return all the phone calls in the phone bill for the customer to give a name that that begin between the 2 times that are specified. So what you're doing is querying the phone bill again for the calls that begin between the 2 times that are specified on the URL. And again, yep, it looks just like it does on the command line, separated by spaces, and so a phone, a date and a time like that. And again, the application supports multiple phone bills. Anything else I can tell you sort of about the fundamental requirements of the server side of the application, what the REST APIs need to do? Check for questions online. Nope. We'll see if we're good. Okay. Okay, there's also a command line program. Sorry, it's listed Project 4 here. It should be Project 5. I'll try to remember to fix that. And this is a command line program, just like you're used to, that looks pretty much like the ones from the earlier project, but it's got actually it has some different options. So, the idea here is that the command line program is used to populate the information in the server, and then also execute that query with a new dash search option. So there are there are options and there are arguments, just like there have been in all of the other programs. Notice that the name of the jar is different too. So it's customer caller number, callee number, begin and end, just like you're used to. But there are some new options. So there's an option for the host name, an option for the port. Um, Note that if they aren't specified, the program isn't very interesting. And so I'm pretty sure that all of my test cases specify host and port, probably except for the one that's like the README or whatever. So, don't try too hard to fulfill to make do something sensible when host and port are not specified. But there's a host option, there's a port option that tells the client, hey, here's which server I'm going to request information from. There's dash print and dash readme that you're used to. And then there's also a new option, which is dash search, and that'll search for the phone call. So that'll invoke the API that queries. And note that when the search option is provided, only the customer is required. So customer has to be there. If no other parameters are specified, then you pretty print all of the phone calls for that customer. If begin and end are specified, then you only print the phone calls that start between the begin and the end time. And so what the client does is it pretty prints, actually always pretty print, well, when you have one of these query calls, so either when you're looking for, sorry, query invocations of the REST API, it should it should invoke the REST API, take the output, and then pretty print it to standard output. So in project 5, you're still using a lot of the same code from project 3. Hopefully you don't have to modify it, right? You're still using your text separator, you're still using your text parser, you're still using your pretty printer, but there's no files involved, right? It's different. And the lesson here is that the text dumper and the text parser and the pretty printer really shouldn't care about the destination that it works with or the source of the thing of what you parse. It can come from a text file. It can come from the result of invoking a REST API. You can use Java IO, readers and writers, and all those kinds of things to make it very abstract. Here are some examples. I'll go over. Hopefully, this will make it a little bit more concrete. So here's what it looks like to add a phone call to the server. Right, you specify the host and client, and then all of the parameters, so including the the phone numbers and the start and end times. I saw a question come in. Does begin and end specify phone call begin whose durations are between the begin and end time, or whose begin time is the specified one, whose end time is the specified one? Good question. Thank you. Yeah, I tried to clarify that up here, but let me just go over it again because it probably wasn't super clear. Yeah, so it's all the phone bills calls that begin, that begin between the begin and end time, right? So what you're querying on is the begin time of the phone calls, and yeah, I can see where it's a little confusing that one of the parameters is called begin and the other one's called end. I'm happy to, I'm open suggestions to things that would make it a little bit more clear that we're just querying on the begin time. That's all we're doing. Did I clarify things? Thanks for asking about that. Yep. Where I said yes. Yep. Excellent. Okay. Here's some examples. Again, here's how to add a phone call to the server. For searching, again, that begin between the two times. Here's what it looks like. You just specify the dash search, and then with the customer name, and then the begin time and the end time. So this is everything in the month of March. And then it should pretty print all the calls in the month of March. And if there aren't any calls between the two times, there should be a message saying so. And then if you want to print all the phone calls, you just provide the customer. So that's the capabilities of this program. There's new functionality in the dash search. Everything else is probably familiar, but what else can I tell you about what the program needs to do? Yeah.
Apologies if you already covered that, but since we're using a new directory, it mentioned that it's using a project 4 class. Is that calling our old project 4 class, or is it just there?
That's a typo on my part. It should be project 5 for this one.
Okay.
Yep. No, and you're absolutely right to be confused by that. Yes. So then I'll leave it up to you how much of your like project 4 main is still appropriate here. You'll have to do things like parse dates. So maybe some of it can be, maybe a lot of it can be reused. But the thing is that, and as we'll see this in the code, instead of just like instantiating, well, actually, you might no, you might instantiate. No, we probably won't on the client side. You probably won't instantiate a phone bill. You probably create a phone call and go tell the server, "Hey, go create this phone call."
But it would be more focused on the database in like involvement versus.
It'll be yeah. We'll see that there is a an object. There's a object that is basically like a wrapper over the REST API. It's a REST API client Java object that speaks Java terms like it takes a phone call. Okay, and add that phone call. Actually, we'll see that when we refactor. But yeah.
Thank you.
Yeah, no, great question. Great question. Are there things I can tell you? Yeah. Oh, great. Yep. So the project 4 is not relevant in terms of the database. That's correct. You're not using the database in this one. Project 4 is all about the database. You'll demonstrate that you can use that. You're not using you're not writing to files in this project. You've already demonstrated you can do that. Instead, now what you're working with is the data that goes back and forth between the client and the server. Yeah, great. Nice. Okay. Just finally, some error handling. So it's the usual stuff. Hey, if the command line has an error on it, something is malformed. But also, hey, if you can't talk to the server, there should be a nice error. Or if there's something that's past the REST URL that isn't formatted correctly, yep, pretty nice error. So again, no stack traces. Like just saying 404 doesn't help, right? You'll get a 404 back, but you need to interpret that in a way that the human can understand. And I think really everything else I've got here, actually, it's okay. Some additional notes. Yeah, if you want to look at how to implement a servlet, there's my family tree servlet code there. We'll take a look at the HTTP request helper, maybe next week. If you're running on a machine that's shared with other people and someone else is already using port 8080, you can run Jetty on a different port by setting this -d jetty.http.port to some other value. Note that the submit script will submit most things, certainly your .java code, but as usual, it won't submit your pom.xml or the web.xml, which is the configuration for your web application. You shouldn't need to change it, and so then it doesn't get submitted. And then, yeah, you'll need to copy in code from your other Maven projects here. Don't re-implement it, right? Just copy it in. IntelliJ should make that pretty easy to do it. And same thing for like your resource files, like your README or anything in your in your tests to make sure you got the correct amount of coverage. Oh yeah, I just did not update this for Project 5. I'm going to do this during break. And then here you submit it using submit.sh. And the submit script is smart enough to know that Project 5 is it corresponds to the phone bill-web directory. So that's the Project 5 assignment. Anything else you want to explore before we take a little break? Of course not. You want to take a little break? Silly question. Nope. Cool. Okay, let's take 10. Let's take 11. This break goes up to 11. Let's Rob Reiner. 6:35. And we'll reconvene. And we'll do for the rest of the class is we'll look at the code to start orienting ourselves towards all the pieces parts here. Yeah. Yeah. Let's just look at some code. Hey, okay, so we're back. Hey, during break, I went and fixed the assignment, and so then now it says Project 5. Sorry, I can't update the diagram just yet. So that's Project 4, but the name of the command line program is Project 5. So in the first part of class, we talked about the Project 4 assignment. We created the project. Hopefully, those of you who are playing at home got everything working. We're going to spend the rest of the class looking at the code that was generated and starting to walk through this. And to understand the code and how it's invoked, we're going to use the debugger. So we're going to see how to attach a debugger to a Java project so that we can really step through the code and see what gets executed when. So let's see here. Let's just go and look at the code. Okay. Here in in our checkout of our repository, we've got our phone bill web, and we've got the usual setup of our code. We've got integration tests, we've got unit tests, and we've got our main code. There's something called the web app directory. You won't need to change this. This is basically the configuration of the web application. You can learn about it in the lecture, and you can peruse it on your own. We've got Java code, as always. And we've got the phone bill servlet, the REST client. Project 4 should be renamed Project 5. So let's just do that. Refactor, rename, call it Project 5. We want to, let's search in comments and strings. Now text occurrences 2. Should be good. Let's see here. It found, oh yeah, there's an integration test. You'll want to rename that also. And let's do that. And then, oh yeah, oh man, it's all over the place. Sorry, guys. Refactor. Let's just go back and look at what's changed. The POM, the integration tests. Okay, good stuff. The POM is probably just, yep, is the name of the main. Is Project 5. Great. Okay, so then I think this is okay. Let me just run the Maven clean verify again, just to make sure everything works. Great. Okay, good. And again, sorry, I forgot to do that in preparation of the course. Rename Project 4 main class to Project 5. Project 5. Commit and push. Okay. Change the POM, so I need to reload. I don't think there's anything significant. Okay. Now, I've been talking about the servlet thing. And so let's go look at the servlet. So the servlet is a Java class that responds to web requests, or it responds to URLs that are requested from the servlet, from the web application. So it's Java code, and this is cool. And so then it uses Java things. So for instance, oh yeah, sorry. And as you learned about in the lecture, there's something called the Servlet API. So going back to the diagram here, I'll make it a little bit bigger. Your code is right here in the phone bill servlet. And the servlet lives within this web application. That's the thing assembled by the program. There's the web.xml that configures all of that. And then all of this runs inside this Jetty web container. And the job of the Jetty web container is to basically be a web server and respond to URLs. And so when it gets a URL, like, give me the, get the /phone bill /calls !customer equals Dave. The responsibility of the web container is to basically pull apart this request and figure out where it should go. So everything that begins with /phone bill that has a resource location of /phone bill will go to your phone bill web application. And within that, everything that has /calls will get routed to your phone bill servlet. And that's, that just sort of ought to work out of the box. And so you shouldn't, so hopefully you don't really, you don't have to mess with it. You shouldn't need to really know that too much. The bottom line is that, hey, listen, when you call, when your URL that is /phone bill /calls is requested, then it goes to your phone bill servlet. Now, Jetty is code that you didn't write. And so how does Jetty know to invoke the code that you did write? Well, there's an interface that both of them share. And those interfaces are called the Servlet API. So there is the standard API that's implemented by all web containers. There are different kinds of web containers. There's Jetty, there's Tomcat, there's, you can invent your own as long as it conforms to the API. And as long as it, implements the API, then you're all set. Same thing with your servlet code. Right? If your servlet code leverages the Servlet API, it can run inside any compliant web container. So what does that Servlet API provide? Things like the HTTP Servlet class. So HTTP Servlet is from this Jakarta Servlet API, and that is the superclass of all servlets that respond to HTTP requests. And so, yep, there's some methods that you inherit, like do get and do post. We'll take a look at those later. Actually, we'll take a look at those right now. So as you learned about in the lecture, there's these servlets, and then your servlets extend a standard API like Java servlet, HTTP servlet. And the way that a servlet handles or responds to a web request is by overriding methods inherited from HTTP servlet. And there are methods that correspond to the various HTTP verbs. So again, as you learn about in the lecture, HTTP has this notion of not only a resource of a location of something to go fetch via HTTP, but also there's a verb, which is like sort of the thing that you do to it. And so there's get and there's post, there's put, there's delete, there's header. I explain it all in the lecture. The ones that you're going to care most about here are get and post. I think there's also a do, delete, and we'll probably see that next time. So the get and post methods are all about responding to a request. And so the do get method that's inherited from HTTP servlet takes two objects, an object that represents a request and an object that represents the response. And this is a very Java thing to do, isn't it? Oh, good. You've got something, you model it as an object. So the idea here is this should feel familiar to the Java developer. And so then, yep, you're just using objects that abstract away all of the specifics of the HTTP protocol, of encoding data, all that kind of stuff. And so then from well, we'll take a look at it in a minute exactly what comes in or was available in the request method and the response method. But let's take a quick look at sort of what it does, and then we'll use the debugger to actually go through these things in detail. So when phone calls, when the /phone calls URL is requested with the get verb, the do get method is invoked. And what is the first thing we do? Well, we set the content type to say, hey, listen, the type of data I'm sending back to the client is just going to be plain text. And so then, hey, if you were serving up an image or something, it would be like, text JPEG, sorry, it would be like image JPEG. You could do, text JSON, anything you want. And then what we do is we we get information from the request to do things like the following. There is this get parameter method, which then looks for the parameters for the URL for like, hey, the word. So it's like, oh, yeah, like if we go back and look at, sorry, let me start. Let me start this up again. If we go back to, sorry, let me just put something in there. So if we go back to this thing right here, I'm going to make it more narrow. If we go back and we ask for the definition of me, look at the URL. It's /phone bill/calls $word equals me, right? That's the parameter to the HTTP query. And so the way you get at that in your Java program is that you use the get parameter method. And we'll see how that works a little bit. Now, the word is optional. So if word isn't specified, then we just write the definition. Sorry, if the word is specified, we write the definition. We print out get the word. Otherwise, we'll get all the dictionary entries. And that's basically, when we said get, it says get me, because that's what we were doing here in the web browser, because we were doing word equals me. Okay. So that's a high level what the get method does. It's pretty straightforward. But now let's walk through it with the debugger. Okay. Have you all used debuggers or know what a debugger is? What debuggers have you used? GDB. Okay, I'm sorry. Okay. Guess what? We're not using a command line debugger in this course. Yeah. So debugging. Debugging is pretty straightforward. You have to enable a debugger. You have to enable the JVM to accept a connection from a debugger. And so then, here in the Getting Started repository, there is a section for, great, yeah. How can I use a debugger to uncover the source of problems in my project? Okay, so you can read all about it here. Let me make it a little bit, okay, I'll make this a little bit wider. Why do they do that? Anyway. Oops. Go back, please. There we go. Okay. The JVM itself has the ability to be debugged if it's not on by default, which is a reasonable thing to do. You just don't want anybody to be attaching a debugger to your program. It'll slow it down. It'll get in the insides, can mess things up. So when you run your JVM, when you run your Java program, there is a command line option to the JVM itself, to the Java executable, that will enable the debugger. And it's kind of verbose. There's a lot of options and stuff like that. I'm not going to explain what all this stuff means. I don't know what most of that stuff means. All I know is that it works. And I've got an example of it here. And so like if you run, so if you run Java with this, big old command line argument, what it'll do is it will run the program. And actually, because it says suspend equals yes, it will start the JVM, but it won't execute the program until a debugger attaches to it. We'll see that later, not tonight. We don't want the JVM to wait for a debugger to attach when it comes to when it comes to running the server. We just want the server to start up, and then a debugger will attach, and then it will set a breakpoint, and it'll stop when the HTTP request is received. So instead, what you want to do when running with Maven, you want to set an environment variable called Maven ops, and then this is basically the options that are added to the JVM command line of Maven, so when it starts up, the whole Maven process, including the Jetty web container that it invokes, that it launches, will also be in debug mode. So we're going to, this is suspend yes. I don't think we want that, but whatever. We'll just copy this. We're going to quit this. We're going to set the environment variable. We're going to say suspend equals no. Suspend is basically suspend no says, listen, start the program, let it run, and then a debugger will attach later. So we're going to set that environment variable, and then we're going to run Jetty again. Probably someplace in here it said at the very beginning, oh, so much output. Oh my goodness, so much output. At the very beginning, hopefully it said, sorry, where's my command line? Oh, there it is. Listening for so this is basically the message that says, oh, your debugger, it's you can attach with a debugger. So basically listening for transport DT socket at address 5005. Okay, there's a lot of ports that we're going to be talking about. One of the ports is the debugger port. That's 5005, as opposed to the HTTP port, which is 8080. Both of those ports are opened by the same JVM by the Jetty container. So again, we're going to go down to the bottom. We've got, let's see here. If I do this, just go back to, do I do this? No, I don't. Oh, geez. Okay. So now what I've done here is I've enabled I put the Jetty into debuggable mode. And so now I can go and let's see here. This is going to return a 404 because it doesn't exist anymore. So I'm going to go create it. Oops, I'm going to go create it. Yep, there's me, a name I call myself, and as you can see, it's it's just it's outputting stuff over here. Now what I'm going to do is I'm going to attach IntelliJ, the debugger in IntelliJ, to the JVM that's running on port 5005. And here's how I do that. You've probably seen the run configuration up here. You probably use it for your unit test or whatever. You can create a new configuration, which is for debugging. So you add a new configuration. It's called remote JVM or something like that. Yeah, remote JVM debug. And I'm just going to call this localhost port 5005. Oops. And this is how you can configure the debugger client that's in IntelliJ to to connect to a remote JVM, right? IntelliJ itself is a JVM, is a debugger client, and there's also the JVM that runs the web application. Again, lots of processes stuff in this part of the course. Let's see here. All of this stuff is as what you'd expect. Yeah, attached to a remote JVM on localhost port 5005. If you want that command line that was in the on the GitHub README, it actually provides it to you here also. which is kind of nice. And this looks all good. So I want to, I guess I want to apply that. Oh, and I can click debug. I can just run it from here. What else can I do? Nothing here. Okay. I can just click debug. And what that does is launches the debugger and attempts to attach to the process running on localhost 5005, or sorry, that is opened up the port on port 005. And it looks like it was successful. And over here, okay, it doesn't print anything out. But yeah, it's like connected to target VM, so I think we're okay. And so now what I'm going to do is if I click over here in the margin, I get a red dot on the line number, which says there is a breakpoint there, right? A breakpoint is where the debugger is going to stop. So now when I interact with the servlet, I'm going to reload. Actually, no, I'm going to go back. I'm going to say, yeah, let's look for all dictionary entries. So I'm going to click submit. And now IntelliJ woke up and said, wait a second, you hit a breakpoint, right? So now my do-get method has been invoked. And now I can use the IntelliJ debugger to navigate this code. So here's the first thing that's going to set response on the servlet. Actually, before I look at the code, let's look at the objects that are passed in. So my do-get method takes an HTTP servlet request and an HTTP servlet response. And here in the debugger, you can interrogate those objects. And so this object is actually an instance of this org eclipse Jetty server request class. Okay. Do I really care? No. And all I care about is that it implements the HTTP servlet request interface. So this code, the code just needs to program to the interface. Actually, what you get at runtime is something specific to Jetty. Makes sense. And so you can look at the request object, and you can see it's got, oh my gosh, all sorts of information, data, the URI, the method. This is all like the stuff it's got. This has got like all the fields it has. But you can also do things like evaluate expressions here. So if I right click and I go to evaluate expression, which is option F8 here, I can do things like I can say invoke a method on the request. And I want to say, oh, I don't know, get method. Okay, it's a get method. No, sorry, sorry, the HTTP method is get. What else can I get? Get headers, maybe, I don't know, there probably aren't much in the way of headers. Query string. Actually, that might not be that interesting. It's empty because if we go and look, there is no, or there will be, there's no query string there on the calls. This maybe isn't the most interesting example. But as you can see, you can get, information about your cookies or, oh, here's like the request URI. So that's that's the request that's fulfilling. So you can get interrogate information there, which honestly, probably the only thing that's interesting in this project is the parameters, and we'll see how to get that later. So anyway, but you can use the debugger that way. Hopefully these concepts are familiar to you, but if you haven't seen it in like an IDE, it can be kind of eye-opening. So now let's step through the code to see what happens. When I'm just going to do step over. So if there's a method, it's not going to dive into that method. So the first thing I do is set the response type on the response. Then I'm going to ask for the parameter. I'm going to ask for the value of the word parameter. I expect that to be null. Oh yeah, word here is null. So when I call get parameter, the word variable has a null value. So then word is null. So this code will not get invoked. Instead, I'm going to go to this else statement. And so I'm going to log, get all dictionary entries, and I'm going to write all the dictionary entries to the response. And we'll dive into that in a little bit. Okay, so now I'm done with that method. I'm going to click continue here or resume program. And now, so the debugger said, great, we ran it. And now the debugger is sort of done for right now because I told it to go. And sure enough, it loaded all of the phone, all the calls in the phone bill, and it's only got one of them, me, a name I call myself. I'm going to add another one. Ray Drop Golden Sun, it's still here. That's nice that it's populated, I guess. Cool. So Ray Drop Golden Sun. Now, when I print all the dictionary entries, I'm going to go through all this again. I'm just going to continue. Good. I get both of them. Okay. So again, when I invoke this /phone bill /calls with no parameters, it prints out all of them. But now let's do the same thing with me, a name I call myself. Actually, how do I just do this? calls, and I'm going to say word equals me. So I'm just going to hit the URL directly. I'm not going to use the form. So when I load this URL, when I hit return, it does a HTTP GET. Here my do get method. Now let's step into the code to see what it's doing. So I'm going to step over this thing because I don't really care about the implementation, but I'm going to step into the implementation of this get parameter method because that's a method here in my phone bill servlet class. So what get parameter does is it takes the name of a parameter, in this case it's going to be word, and it takes the request. It's going to ask the request for the value of that parameter, and it'll handle either a null value or an empty string. In the case, returns null. So here, I'm going to call get parameter from the request object, and the value of the word is me, because that's what I passed in on the URL right here. Word equals me. So what we're doing is we're parsing out this query parameter. And so, okay, the value is me. It is not null and it is not empty. So then I will return me. And now the word is me. That was passed back from the method. Word is not null. So I will log it. And we'll see here that we just logged it, get me. And now we're going to call this write definition method. So I'm going to step into that. Here I am in write definition. And now let's talk about sort of like what this phone bill servlet does. It has this object, this field called dictionary, which is just a map of string to string, this empty hash map. And this is the thing that stores all the key, all the word definition pairs. And so it's got that. So I'm going to go back to, I'm going to double click on my write definition method. Actually, I can also say what, F4 or something. Yeah, anyway, double click on it to go back to where yeah, by the way, this is the execution stack right here. So this is what code is executing. So here I'm in write definition. I can go up on the stack and see where I am in my do get method. Now I'm going to step through this code. I'm going to get the definition from the map. And here the definition is a name I call myself. And if the definition isn't found, then it's going to issue a 404. Yeah, and the way you send a 404 back to the client is by setting by invoking the set status method on the response with one of these constants that this one is sc not found is 404. But I did find it. So what I'm going to do is I'm going to ask the response for I want to send some data back to the client. I want to send some text data back to the client. I want to write some text data. In Java, how do you write text data? You use a writer. So one of the really cool things about the Servlet API is that it leverages the Java I/O APIs that you learned about in week 3 or whatever, right, to do the output back to the client. So every HTTP response has a writer, excuse me, it's a print writer that when you write to that print writer, what it actually sends it to is back to the client. And this is super convenient, right? Because you've already got stuff like, well, you probably have stuff like your text dumper or your pretty printer that takes a writer. So you don't need to, so your phone bill classes don't need to know that they're running in the context of a web server. They're not being invoked in the context of a servlet because the servlet uses standard APIs. So what do I do? Okay, I go and okay. So what I've got is an implementation of text dumper that dumps a map of strings, which is basically going to be like your text dumper. Instead of dumping a phone bill, this one dumps a map of strings. So I go and I create a map of strings with a word definition, and I create my text dumper, and I call it dumper.dump. We're not going to dive into the details, just print some stuff out. But because the text dumper was created from the print writer that came from the servlet response, the destination, where the text is dumped, is going to be the response back to my servlet. Now I get down to here, everything went okay. All the logic is happy. So I'm going to return, I want to set a status code for my response of 200. Everything's okay. And so the way you do that here, again, setting status to 200 here, everybody was happy as opposed to like up here was a 404 or something was missing. Oops, what did I just do? No, did I say go or something? That's weird. Oh, I think I hit run to cursor for some reason. Yep, and there's the definition of me all printed out. One more thing to show off. Okay, and so this is the way the do get method works. So do get, you go and ask the parameter, you go look up the word in the dictionary, and then you print it out. And really write all dictionary entries. You can imagine that works the same way, actually pretty similar. Here you just create a text dumper again, and then you dump the entire dictionary as opposed to like the one entry that you found. Okay. Make sense? I hope. Anything? I'll pause for discussion. Anybody's got anything? Cool. Let's take a quick look at the do post method. I set a breakpoint here, line 56. I'm still attached to the debugger. Now, post is what's invoked when you go and create a pair. And actually, let's go or create a definition. Just do it from the command line, just to show. So I'm going to run the the command line program. Said me, let's see here, fa, a long way to run. So here I'm using the Java command line, but just to demonstrate the fact that it calls the servlet, it calls the server code also. Poof! Here I am. The debugger popped up because the do post method was invoked because I sent a post request to the web server via the Java API, and we'll look at that later. So you do some similar stuff here. We're going to say, hey, what I'm returning is just some plain text, and once again, I use the get parameter. It's like, hey, was there a word? If there wasn't, then I'll issue a required a little issue there. Required parameter is like a 402 or something, 412. Yep. But anyway, so you basically get the required word parameter, you get the required definition parameter, and we don't need to look at get parameter, so I'll just step out of that, go back up one, get definition. So here we go. Word is fa, definition is a long way to run. I'll print it out. We'll put the word definition pair into the map. So we'll basically make a mapping between those two. And then I've got this messages thing that basically has like a nice little, message saying like, oh, look, here's what we define the word as. And that's what I'll write back to the response. Now, the post doesn't write like the contents of the dictionary. It's not the way it does. It just writes a little message instead. And so I'll go over that. We'll flush the print writer just to make sure everything got written out. And we'll say, status okay because everything worked as expected. So we'll go over that. And you can see here, probably hasn't sent anything back yet. So notice that my Java program is paused right now because it made the call to the server, but the server is being debugged. The server hasn't returned its response yet. And so then the client is waiting for the server. So, right, debugging, right? Everything's, kind of freeze. Yeah. So, okay, we're done with this method, so I'm just going to continue. I continue and like the debugger, okay, went away. And now my program completed. And what it did was it printed out that message that was returned by the program. Well, sorry, returned by the REST API. And really, those are like the major pieces parts of the servlet. It's pretty straightforward. It's got to do get that responds to get. It's got to do post that responds to posts. And so then, one of the things you'll need to do for the assignment is implement the capabilities described in the project assignment in these do get and do post methods. Anything else I can tell you about that? Anything else I'd like to know? I'm going to detach from the debugger. I'm going to say stop the debugger right here. And so then that's cool. So I don't this work first up. I do want to give you just like a little preview of what we'll be doing next, some of the other stuff. So there's lots of other things here in the source code. There's the main project, and there's also there's something called the phone bill REST client. So this is Java code that runs on the client side that is invoked by the Project 5 main. And this is something that knows how to form the calls to the REST API. So this is basically doing what the web browser does. It formulates, it formulates an HTTP request that then is delivered to the web application, to the web container, and ultimately goes to your servlet code. And we'll take a look at this later. It uses this class called HTTP request helper to do a lot of the heavy lifting. That way you're not like having to worry about formatting URLs and putting everything together. It's intended to make that easy. I'll let you be the judge of that. What's really interesting about this project, and we'll dive into this later, is that there are unit tests and integration tests for all of this code. So, your servlet, even though the servlet itself is going to be invoked inside a web container, you still want to be able to unit test it. You still want to be able to validate it's going to do the right thing. Because as you've seen, it's kind of slow. Well, actually, maybe you haven't seen. You can imagine that might be kind of slow to like write a little bit of your servlet and then like go restart your Jetty and then somehow test it. That can be a very slow thing. What you really need to be able to do is write unit tests. Well, you can, but one of the things about your servlet is that your servlet like takes these, it takes these HTTP servlet requests and HTTP servlet response objects. And in your unit test, you're not going to have one of those, right? The unit tests don't run inside of Jetty, they run outside of Jetty. So what you'd like to be able to do is invoke this do post method and then send it objects that implement the HTTP servlet request and HTTP servlet response interfaces that then the code can interact with, but because the code's programmed to the interface, it doesn't really care that they are test-only objects, they're not real servlet objects. And so we'll see how you can do that using the Mockito API for creating mock objects. And that was in the lecture. It's kind of wild stuff, but like once you figure it out, it's super powerful. So it's possible to test your servlet even though outside of the web container that it runs in using these mock objects. And we'll take a look at that next time. So you can write unit tests for all the code. You can also write integration tests for all the code. And the integration tests, actually, the integration tests require that the server is really running. So what you do is, let's say I've got, here's just use the Project 5 integration test. So if I go to run it right now, you'll notice that I stop the server. If I go to run the unit tests, if I go to run the integration tests right now, everything should fail spectacularly because, connection refused. There's no server running. But now if I run the server is running. I will run the tests again. Everybody's happy because it was able to connect. And so when you run the integration test for Maven, actually what Maven does first is it starts up the Jetty container, deploys web application, runs the integration test, and tears everything down again. And so then you have the same kind of development environment and testing capabilities that you had in your first projects that were much simpler. You can still do all of that stuff here in the REST API project, although your unit tests get a little bit more complex because you need to mock out these objects from the servlet API. Nice. So this is good for tonight. We're going to put Project 5 down for a week. Be thinking about it though. And because next week we are focusing on mod programming. I'm looking forward to seeing you all then. Have a great weekend, everybody. Thanks for joining, folks.
Thank you. Have a good weekend.
Thank
You too.
you.